We are really excited at REI to talk about this topic. It's really popular now. Everybody's talking about AI, and the team here has done some good work in using AI in a practical manner. And we hope to share with you some use cases that we have done today, and hopefully that gives you some insights for further developing AI within your respective organizations. The end of this webinar, we will be taking questions, and hopefully you can jot those down as we speak. And at the end of it, if you can type those questions out, we would really appreciate it, and we'll get to as many as we can in the time allotted. Also, we will be posting this webinar next week on YouTube so that you all have access to it as needed. Given that, let me first introduce the speakers for today. My name is Sanjeev Pulapaka. I am the AI Competency Lead at REI Systems. I've been the lead solution architect here for the last couple of years and have led various proposals, and also have led the application of AI in some of those proposals for the government organizations. I'll turn it over to Joe.
Hi, my name is Joe. I'm a machine learning engineer in the AI team.
My name is Nikolai Sorokin. I'm a machine learning engineer / data scientist in REI.
Hi, my name is Rahil Bagheri. I'm the data scientist in REI.
Thank you, guys. So these are all wonderful machine learning engineers who have really helped us out here in furthering the capabilities at REI. Just before we get the actual webinar started, let me give you a quick spiel about REI Systems. We have been founded in 1989, and we have sustained decades-long customer relationships. So our first customer was NASA, and we are still with them today. And we focus on providing several solutions in the technology space, including grants management, analytics, agile software development, CI/CD, application modernization, and platform-based solutions. We also complement some of these services using, for example, with strategy, change management, investment analysis, technology business management, and so on. We have about more than 500 employees at the headquarters, and we all really enjoy the work that we do in delivering these mission-critical solutions for the government. Okay, so having said that, let's go dive in right into the webinar today. All right, so the introductions, we had the introduction so far. I'm just going to talk about a little bit about the artificial intelligence world as a whole, just to kind of get everybody in, level set everybody. And then I'm going to give a little bit of context around how we've applied AI in an organization and what are some of the best practices that you can use. And then we'll jump into the use case demos. We have 4 use cases to share with you today, and hopefully you'll find them useful. And at the end, like I said, we'll have the Q&A session. Okay, so we've already gone through the introductions. So let me dive into the artificial intelligence world. So that word has become so common in everyday life, and it is difficult to grasp exactly what it means. It can mean different things to different people. But from a practical standpoint, it really revolves around a few key paradigms, I would say. So one is natural language processing. As you can see, this graphic here does a good job of summarizing all these paradigms. So we've got natural language processing, voice processing like Alexa, robotics and motion like self-driving cars, and so on and so forth. But again, I would focus a lot on the natural language processing aspect because that's where we are seeing some of the biggest gains. So how do these things work? there are various ways a machine could learn. So there's supervised learning where we actually give data to the machine, and we train the machine and saying, hey, A is equal to B is equal to C. So now that you know this particular pattern, next time you have to predict something, you can do it. Then there's the unsupervised learning where you give it a whole bunch of data and then it's trying to find out patterns and clusters and things like that. Then there's reinforcement learning where you give it's some kind of a reward mechanism where you actually show the data and say, hey, if the machine is able to find some patterns, then you say, yes, that's good. So you reinforce that behavior and then you again feed that back into a pattern of learning. Then we have various methods. So we have neural networks, and neural networks can be used for deep learning, regression, decision trees, random forests, and also those are different methods. So that's the ability to reason. And finally, we have all the supporting technologies like the platforms, the APIs, sensors. So we've got Azure has its own platform now. We've got Amazon that is SageMaker, and pretty much hundreds and hundreds of tools out there right now. So how do you make sense out of all this, and how do you apply all this, especially in a grants context? So when we go into an organization, we have developed a framework that is really helping us guide, organizations how to implement AI. So let me walk through some of the various aspects. And we have developed this framework. The framework consists of 7 essential elements. First, we have the data. So that is pretty much at the heart of everything. I mean, majority of the time we spend in any of these exercises regarding AI is to figure out what the sources of data are, how to get them, how to collect them, how to harmonize the data, and then how to standardize it. So it really goes back to data. We have data all over. We have structured data, unstructured data. And then the size of the data is also very, very instrumental. Then we have quality of the data. We have to make sure that the quality of the data is good. Otherwise, there's no point in getting a result, and that result is really not yielding to any benefits. So once again, there are standard methods to use to get the data quality or increase data quality. So metadata management is one. Data stewardship is one, finding data lineage. So those are all the various standard quality practices that you can adopt to increase the quality of the data. Then there's tools, and so there's various tools out there. You can, like I said, we've got Azure, we've got Amazon, we've got Google, and various packages. We've got TensorFlow, sklearn, Python. As a language is R. You can use so many different tools, and there's pretty much a tool for everything now. So it becomes very important to identify the use case and what's the appropriate tool for that use case. It could be a generic platform across the entire enterprise, or it could be a specific tool for a specific example. Then we go into governance. Governance becomes key because when you have data, and when you're trying to use the data for key decisions or key insights, you want to make sure that there's some governance around it. Otherwise, it could be used for nefarious purposes, and also it could be pretty much uncontrolled. So we come in with certain recommendations around governance and how we can establish governance without really killing the entrepreneurial spirit of the whole analytics culture. We have change management, and here this becomes really key for AI because it's so new. People are resistant to it for many reasons, and there's good reason why. For example, some people don't trust it because of the so-called black box enigma. So a lot of people think that, hey, AI, some of the techniques they use, you really don't know why the machine is predicting certain things. And so then it becomes very difficult to rely on what the machine is revealing to us. especially for mission critical decisions. So in that situation, yes, that is partially true, but not necessarily true for everything. So neural networks, for example, it is difficult to figure out what exactly or why the machine is concluding or is giving us the insight. However, there are other models, random forest, regressions, that actually give you a lot more insight into why the machine is coming out with the recommendations. So it becomes very critical to figure out what the use case is, how mission critical it is, and then what technique to apply given the circumstance. Finally, I mean, I would suggest that our proponent for expanding this across the organization is start small, and I think pretty much that is the agile way. And you start small, you get a small use case, identify the right method which applies to it, and once you get that going and people get confidence in it, then you can start expanding into other situations. So that, in a nutshell, will help with the culture, promoting AI, and then reducing fears about like job security and things like that. Because at the end of the day, we're not in a place where we can say that AI will replace jobs or anything like that. It's just a supplement at this time, and I don't think we're at the place where the next generation of AI maybe, but at least not for this coming 10 years or so. Our framework, we've used it successfully at HHS, specifically at HRSA, and this is called the Modern Analytics Platform. It was given an ACT-IAC award. So that includes the comprehensive analytics framework, and it also has machine learning and AI built into some of the aspects of it. Okay, so let's look at the grants lifecycle. So we have the typical phases here. I've listed it out, but hopefully people are familiar with this. If not, I'll just walk through it. So we have a planning phase where the grant officers have to figure out what are the programs they need to fund and how much funding should be given, and what are the avenues for funding, who qualifies, and things like that. So that's the planning phase. Then there's the application phase where awardees or grantees would apply to receive the grants, and they send in all these applications, and the project officers have to make selection and give somebody the award. So that in order to select the potential award, they typically go through a peer review process where the application is reviewed with multiple people and screened and so on and so forth. Then there's certain pre-award qualifications that are made, and then there's a selection. Finally, there's the actual award to the grantee, and funds are transferred over. Once that has happened, then the grant or the grantee agency or the agency needs to make sure that the grant is being used according to the purpose it was developed for. So in that situation, in the post-award phase, they will need to monitor the performance of the grantee and make sure, again, it's on the right track. And finally, at the end of the period of performance, the grant is closed out. So that, in a nutshell, is the grant life cycle. And we feel that at least AI can be applied in multiple phases of this life cycle. So we think that in planning, application, peer objective review, selection, and post-award, there is definite use cases that can be exploited with AI. So I'll just go through a few of them, which we are actually we are testing right now within REI for various agencies. So the first one is the outcome prediction of programs prior to engagement. For example, in the state of Utah, we are implementing a grant system, and there it's all about the education grants. So in this sense, we are trying to come up with models that help us determine how effective the grants are in improving education within Utah. So that is a project currently in progress. Another one which we think will be very useful will be predictions for risk scores of applications. So applications are very, very complex, right? And so they have multiple pages, they have different backup documents, and it can get really cumbersome to go through these and determine who the award winner would be. So our proposition is that we can use AI using natural language processing to actually augment the decision maker, kind of give them supporting evidence and saying, hey, this particular application is more likely to succeed or to actually perform well. So we're trying to develop that algorithm to give them these indications. Then we have a use case for selecting the reviewers for applications. So right now, when applications are received, there are so many that it can be very time consuming to actually go through and do peer objective reviews and actually share the feedback and so on and so forth. So what we are proposing is that we would be able to match the appropriate reviewers for applications. So sometimes what happens is it's very difficult to find the reviewers to manage their time and to find qualified people who can actually review the application. So we are proposing to, or we have actually developed an algorithm where we can screen the resumes of reviewers and be able to match the qualified reviewers for an application. And we will show that to you shortly in this webinar. The second use case we would like to show to you today is determining predictions for a performance. So like I talked about, after you award the grant, the grant agency definitely wants to track the performance of the grantee. And in that situation, it'll be good to know, or at least good to predict how the performance would, how the grantee would perform under certain circumstances. And in that situation, we have developed another use case, which we'll show to you today. The third one is the predictions for risk scores. So in this case, for grantees in the planning and post phase, we have developed another model. So the use case 2 was more about predicting for performance in the sense, how do you predict the performance of a grantee? Whereas use case 3 is more about the risk of a grantee. So in a sense, how risky is a grant in terms of meeting the expectations. So this one actually could be straddled across the planning and post-award phase, because if you know who a risky grantee is, you can use that in your planning decisions. And finally, the use case 4, which we want to show to you today, is chatbots. So we did develop a chatbot for our custom GovGrants product that we use for state and local agencies throughout, and we could potentially use for out-of-the-box federal programs. So we will display that to you today. What are some of the benefits of this? So, you have to name a few. One is definitely increased efficiency. So if you can help the agency reviewers by giving them indications about a particular application, then that definitely increases the process. I mean, that definitely increases the efficiency in terms of reducing the time it would take to process each application. There is a higher return on investments because you can manage risk more effectively, and there's increased productivity because employees can focus on more complex tasks as opposed to spending time on repetitive tasks. So let's move on to use case 1. This is a use case is all about classifying proposals for grant solicitation. So NASA, Small Business Innovation Research, receives several proposals for its programs. So again, it becomes very hard to figure out who the qualified reviewers are for these proposals. So what we have done is we are able to use some programs to process all these the applications, as well as process the resumes, and we, using predictive models, we're able to predict who the right reviewer is for a proposal. So with that, we can give recommendations to the reviewers that are also to the grant officers, saying, hey, here are the good reviewers, or here are the right reviewers for this proposal, as opposed to digging through and finding it and doing it manually. So that saves them put in a lot of time. So I'm just going to now talk about a couple of options there. So if you want to use AI for this, there's 2 ways to do it. First is you can classify all the proposals by the topic, right? So we do that with the neural networks. And then you can classify all the reviewer resumes by that same topic. So again, this is assuming that there are certain topics in which you can classify all the proposals. So in this situation, first step, classify proposals by topic using neural networks. Then you classify reviewer resumes by topic, again using neural networks. Once you have that, then you can match the proposals to the reviewers by topic, and then you can assign the reviewers to proposals. The second option is in a situation where we don't have any topic or which you can classify all the proposals. So in this situation, we can compare proposals with resumes directly using an algorithm called doc2vec, and then we can directly assign the reviewers to those proposals. So now we're going to just give you a quick demo about the second option. I'm going to turn it over to Joe Gu, who's actually going to show you this.
Thank you, Sanjeev. Hi, everyone. My name is Joe Gu, and I'm going to show you a demo of how the option 2 works for resume and the proposal matching process. So we built this UI where you can input to simulate the real use case for grantor proposals and reviewers' resumes mapping. We use REI's job descriptions and REI's applicants' resumes as alternatives to them, so we can show you as a demo. In here, I can insert a job description to this chat box, and then after I submit, the algorithm, the doc2vec algorithm, can return me the top 10 matching resumes for the job description. How this algorithm works is we vectorize the resumes and we vectorize the job descriptions, and then we find the similarity between vectors and pick the top 10 resumes that has the most similar vector presentation to the job description. So I just put a database development engineer's job description in the box, and it returns who are the best applicants for the job description. And we can also see that the job titles for those applicants, most of them are database engineer. Which means the algorithm is working. And I can show you another example. In here, I can input a job description for a software engineer. And after I submit the job description, it finds another 10 applicants with the similar backgrounds. So we can see the job titles they applied for, most of them are developers or database engineers or QAs, which means the algorithms works. But still, we need to improve the accuracy and the performance of the model by increasing more training data and more resumes. So we can improve the model performance, and in that way, we can get more accurate results. I'll hand back the session to Sanjeev and show the next use case.
Thank you, Joe. So let's move on to the second use case. This revolves around analyzing the performance data. So for HRSA, HRSA's mission is to improve the healthcare of, especially of geographically disadvantaged people across the US. And so in order to do that, they do collect data from all the health centers that they give grants to across the US. So once they receive this data, then they analyze, they use various metrics and they analyze all this data and they're able to compare the performance. However, what happens is it's difficult to compare these directly because there are so many characteristics such as demographic and health profile characteristics that could actually impact the performance. So for example, there could be a lot of uninsured people, or there could be a lot of homeless or minorities that could be impacting performance. So it's very difficult to compare directly based on the data. So REI worked with HRSA to develop a model using various techniques to determine what the factors are that influence performance. And once they did that, then they can adjust the performance based on those factors so that they can get an apples to apples comparison of performance across the US. So we used we did the modeling using the R language in this case, and we fine-tuned the model using lasso regression that actually depicted the most influential factors. So if you look at the right, the chart on the right, although it's a little small, I apologize for that, but you will see that this chart shows all the influence of all various types of factors on the performance of the grant. And it indicates, in this case, it's talking about screening for depression. So all these variables somehow impacted how well the health center was conducting the screening for depression. If you see on the top part, you can see where the curve is going towards the right. That shows those variables that specifically affected that depression screening positively. So for example, people with diabetes, the fourth variable from the top, will have increased screening for depression. So that's one of the conclusions from that. Similarly, there's the negative aspects below. If you look at the bottom, people who have actually undergo, like Medicare patients, fourth from the bottom, probably did not get depression screening done. So this is a very interesting type of observation, and all these were taken into account to develop reports in Tableau that people could use to quickly measure the performance of the healthcare center. So I'm going to transition to Rahil, who's going to actually show you the dashboard that was used to help HRSA in this effort. So, sorry.
Hello everyone, this is Rahil, and I'm going to show you guys how the model is performing. This plot represents the model performance metric, the mean square errors. The bars represent the actual depression values for each health center, and the dots present the predicted values for that grantee. As it's shown here, these two values are really close, and the model could decrease the differences between these two values and reach the minimum error. And like as you see, each bar represents to each health center, and the dots are predicted values, and they are really close. And the differences is the residual, the mean average error between them. For example, for this health center, model could predict really well, and the differences between these two values was less than 0.30%. And that was a demo of the performance model. I'll hand it back to Sanjeev to continue on this session.
Thank you, Rahil. So moving forward, use case 3 is predicting grantee risk. So the use case here is all about figuring out the risk of a grantee. We get a lot of data from various places, and so REI has developed a risk management framework. Using that framework, we are able to determine the probability of drawdown restrictions. So drawdown restrictions are typically placed when the risk of a grantee is higher. So in that situation, we can use AI with our risk management framework to figure out what the probability of a drawdown restriction is. So just to give you a quick overview, there is various sources of data. So you can see on the left, as provided by the risk management framework, there's Federal Audit Clearinghouse data, USA spending data, SAM.gov, and so on and so forth. and then we can collect all this data. And we've used various techniques, especially Python and several other in TensorFlow in this example, to create a predictive model which indicates, hey, this particular grantee or grant would be at a higher risk for drawdown restriction, and thus we can figure out what the risk is. So I'm going to have Nikolai Sorokin show you a quick demo about that prediction model.
Sanjeev. Hi everyone, my name is Nikolai. I'll give you a quick tour of our risk analysis tool that we have. So here we simulated the UI possibly for project officer, where we submit the data set with grants. Data set combines several different data sources, particularly from Federal Audit Clearinghouse and the awards data. And in here we pass the data through algorithm using about 30 different measures, features that we analyze through our algorithm. And when we hover over the results, we see the predicted risk likelihood on the y-axis and federal share amount on the x-axis. Additionally, by color, we show the number of terms and conditions placed on a certain grant. Grantees' names are masked for the privacy, but we see their amounts and other features and the risk probability. We also have the results tabulated, and if we're interested to see why the algorithm has given 100% likelihood to certain grant, we just can click and see certain explanation of which factors contributed to the risk. It's a little bit cluttered here for some reason, but we see that this particular grant was masked as high risk by Federal Audit Clearinghouse, had high number of terms, 66, and high number of awards, which means that awards were given to place additional conditions on the grant. Something happened. I'll quickly go back. Yep. Wanted to show you another example of lower risk. For example, 10%. This is what the happy grant looks like. Relatively low term count. No high risk Federal Audit Clearinghouse flags and other stuff. Well, this is how it works, and this is how it explains the decision. And from here, I'm handing it off back to Sanjeev. Thank you.
Thank you, Nikolai. So in this, just to explain further, the red indicates potential dangers or flags.
Yep.
And the blue means that these factors are really not influencing the risk in any way.
Yeah, and the scale on top from 0 to 1 would show the likelihood.
The likelihood of.
Yeah. This particular is 0.0, 0.1.
Thank you. All right, let's go back. We do have one more use case I'd like to share with everybody. So this is chatbots. Chatbots are everywhere, ubiquitous now. Pretty much any site you go to, at least the big Amazon and such sites, Walmart and all that, they will definitely have a chatbot to help you or assist you with your effort. So I think chatbots are going to become pretty much prevalent even within the government space. So you can use chatbots for lots of different things. And some of the key benefits of using a chatbot is that it does provide improve user experience. So if you have somebody that's available to respond to your questions at any point in time, that really feels very much better than having to wait for the next day. For example, if somebody logs into the system at night, you can get assistance with the chatbot depending on the use case. And in doing so, it also frees up time for people to focus on other things. So it does increase productivity and increases efficiency, because you could have one interface that really helps you navigate across different sections of the website. So as opposed to going manually to different sections, I could just go to the chatbot, which will direct you to various places in the site. So numerous benefits, numerous use cases. So let's look at what we did within GovGrants. So as I said before, GovGrants is our own REI's software service-based solution. It's a comprehensive grants product, and it can be used in those situations where the customization is not very extensive. And in that sense, we have used it at various state and local government programs within the country. So within GovGrants, we have implemented a chatbot. We've called it Skynet. And essentially, we developed a few use cases. We targeted a few use cases at this point in time. And the hope is that we would expand on the number of use cases as and when time progresses and we can see the responsiveness. The first, I just want to show you an example use case of how we implemented a simple situation where somebody forgets their password. So, they would log into the chatbot, and then, you can just type in reset password into the bot interface, or you could even, press anything else or type in anything else in your own language. And that's the beauty about the chatbot. It will be able to understand what you're typing. And it comes back with the question, do you need help resetting your password? And should I reset it for you now? And if you say yes, then it's going to ask you for the email address in this case, because the email address is really the user ID. And then from that, it's able to reconcile that user email address to see if you're a valid user. In this case, it found that there was a situation where the email address was not typed correctly. So it does reconcile that and say, hey, would you like to try again? So, we enter the email, and this time it is correct. And if you look from this example, you can see that in this situation, the user account is locked because of multiple attempts, and that happens so many times. So in this situation, it is going to try and transfer you to a live agent. But other times, if it didn't have that situation, it would have reset for you. And so if you are logging in the middle of the night and you didn't have a live agent, this would have been able to solve the problem right away. So very simple example, but it's really very useful, very productive, and really helps greatly in improved productivity and efficiency. What the other functionality we have done? We have done forgot username. We have able to reset locked accounts. We can transfer it to the agent as we showed. And then a very key input or a change that we have made is to reassign tasks within a workflow. So this is internally as opposed to external users. So if I'm processing certain tasks as an officer, then I can actually take that task and reassign it to somebody using a chatbot, as opposed to going through manually several items or several navigation screens. So that really is really helped in improving the efficiency of it. So with that, I think we've come to the end of the use cases that we've planned to show today. Certainly, I would love to take questions from you at this time. And let me see if I've got any available right now, and I can respond to that. So there's a question about handouts, so get a copy of the slides. I mean, we are going to, as I said, post it on YouTube, so feel free to use that next week as you wish, and hopefully that'll help you in what you need. Don't see any other questions at this time. We'll give it another couple of minutes. If there are no more questions, then we'll just call it a day today. And appreciate everybody's time. Thank you for spending your afternoon. Hopefully this was useful. If you do have any questions, please feel free to send an email. With that, thank you very much and have a good day, everybody. Thank you.
Hung up probably.
People are still hanging up? Okay, I think I'm sorry. This looks like a issue with the interface. I apologize if I missed. I think there are a lot of questions here, so I've missed it, and my bad. Let me see if I can get to anybody who's still out there. Is there an optimal size for a grant-making agency interested in using AI? That's a good question, and I don't think so. I think the key is to start out small. So regardless of the size of the agency, I think you can, get started identifying use case and targeting to a very specific example. And the key comes down to identifying the problem, taking a small example, making sure it succeeds, and then you can go on from there. Another question is there an identified use for AI in monitoring? So I'm not sure what monitoring this is talking about. If you're just talking about is it technology monitoring or is it grant monitoring? If you want to just kind of clarify, I can address the question. So I think this is Billy. I see. So the question really is monitoring, specifically compliance with federal regulations. Yes, actually we have done that use case. That's a great question again. We were able to implement a program that is able to understand all the submissions for a particular requirement, and if that submission was compliant with the federal regulations. So we were able to compare it with the requirements of the CFR and then do a comparison and understand how compliant it was in response to the question. So yeah, we actually do have an example that we can share if you're interested, Billy. You're absolutely welcome. Okay, I think that's it. So my bad. I think I'm not used to this interface. Apologize if I missed anybody, but appreciate everybody coming in. I think I can see one more. Wait, let me get to it. Sorry. Damn it, this is bad. Horrible. Okay. Okay, one more question here. Is there grant-making agency? Okay, I think that's the same one. There's two of them, Lakita and Edwards. Get it. Oh, I see. I'm not able to make it bigger. Okay. All right, I think I did get to this. So I think we should be good. So sorry about the confusion, but hopefully everybody's questions I did get to. And thank you very much for spending the time. And again, please reach out to us if you have any questions. I can definitely take it offline. Thank you. Thanks, everybody.